to the lecture on polymorphism, which is the second part of chapter 11. So before we go into the definition of polymorphism, let's look at an example. So in this code, there are 4 classes in 4 different colors. Please pause this video and draw the inheritance diagram using UML for these 4 classes, mostly these 3 classes. Hopefully you have come up with this same figure. So let's examine the code. We have one public class polymorphism demo, inside of which we have the main method and also a method named m. So inside the main method, we call the method m and we pass different objects each time. Then we have another class graduate student, extends student. That means we understand that graduate student is the subclass of student. Then we have class student extends person. That means student is the subclass of person, and class person extends object. So this extends object part is optional to write. Even if we don't write it, any class is by default a subclass of the object class. So this class person is the subclass of the class object. Then inside the class graduate student, there is nothing. So even if we don't see anything inside this class, we know that there will be a default no argument constructor given by the compiler. And since this is a subclass, inside that no argument constructor, the compiler will call the no argument superconstructor. Then we have the class student, and inside the class student we have overridden the method toString. So we have already seen the toString method, which was in our object class. So here in the student class, we are changing the implementation of that toString method. That means we are overriding the toString method. So in the student class, we have with the same color toString method. I am using the same color, depicting that the toString is overridden in the student class. Then in the class person, we have again overridden the toString method. So this toString has a different implementation, and we know that in the object class, toString has a default implementation. The different color means they have different implementation in these different classes. Let's now examine this further. So in this scenario, the first question is this possible to pass an object of type graduate student where an object type is required? So we see that in the definition of the method m, we need to pass, or the formal parameter type is object type. But when we are calling the m method, in the first m call, we are passing an object of type graduate student. In the second one, we are passing an object of type student. In the third one, we are passing an object of type person. And in the fourth one, we are passing the object of type object. So whatever we have learned, we understand that the fourth call, the type here, the argument type and the formal parameter type matches. So here we have no problem. The question is, how do we, or can we at all send a graduate student object when we are expecting a type of object? That is the question. So please pause this video and think about it for a minute. So before we start answering this question, let's now look at this scenario. So, the object is the superclass, and this type of inheritance or any type of inheritance can be modeled using a pyramid. So, the superclass object, this is the first triangle or the pyramid. When we extend this class, object class, we are extending it like this. So the triangle is extended like this, and together this is our class person, where we have we will see, and then we are extending the class person to student. So we're extending the triangle here, and this is our student class. And finally, we are extending student further to get the graduate student class. So inside the person class, it is inheriting the public or accessible data fields and methods from object class. So inside this person class, we have some portion inherited from the object class. This, other than this inherited portion, person class have its own attributes and methods. Then inside the student class, it will inherit everything accessible from the person class. So this blue part, where inside we also have attributes from the object class. Then in the graduate student class, we have everything inherited, accessible parts inherited from the student class, where inside we have attributes from person and also attributes from object. So in conclusion, we can say that every subtype of object is also an object of its supertype. For example, graduate student has everything that is needed for object in itself. So we can pass an object of subtype, for example, a graduate student or student, when an object of supertype is required, because student or graduate student, they possess all the necessary information for object class inside them. So when an object of object class is needed, we can pass a person, a student, or a graduate student. So in total, in this scenario, this method M, it takes a parameter of the object type, but you can actually invoke with any object of its subtype. So an object of a subtype can be used wherever its supertype value is required, and this feature is known as polymorphism. So polymorphism, unlike inheritance, it's not something that you need to write with a keyword, or you need to write something in code. Rather, it's a concept, or it's a design concept.